Ready.
This is Super B Productions, back to you again today, a week later, and now we're going to talk about projectile motion. So, anybody in here kick a football, soccer ball for a living? No. What was your position, Josh?
In football?
Yes, sir.
Receiver.
Receiver. Okay, we'll use you for an example, sir. Josh is running down the field. Okay? He's doing a fly route, just going straight down the chute. The quarterback throws the ball at 62 degrees. It takes realistic time, Josh, for you to catch it downfield. 1.2 seconds, is that reasonable?
How far?
Well, let's say 30 yards.
Like 4 seconds.
All right, we'll go with 4 seconds. And 30 yards is about 27 meters, we'll say, okay? Is that fair enough? So DX is 27 meters. So Josh is out here on the fly route and his arms are outstretched, and here comes the ball, and he catches it and scores a touchdown. And this is DX. That's DX. And that's time, not period. That's how long it takes the ball to go from the quarterback to Josh, who's now fully healthy and running at full speed. So I have a question for you. I have 2 questions, actually. Actually 3. How fast is the ball going this way? How fast is the ball going up and then down? And how high did it have to go?
So apogee.
Exactly, apogee. In other words, what is this right here? dy, apogee. Okay, let's break this down. What is the first simplest thing we can do, Mary Scott?
Find VX.
Yeah, find Vx, because all you have to say is dx over t. 27 divided by 4.
When did we get that from?
About the second week of school. Simple formula for velocity, if there's no acceleration, is distance over time. The simplest formula for velocity when there's no acceleration is d over t, because you assume a constant velocity. For every bit of time, it takes the same amount, every bit of distance, it takes the same amount of time to get there. Would you please try to get a calculator, sir? Hannah, what'd you get? Call it 6.8 because we have 2 figures. Okay, so this component of the pass, Vx, is 6.8 meters per second. Now we want to figure out this part. Yeah, dx over t. So now we want to find this component of the initial velocity. And again, you have your favorite figure in here besides Mr. Banks, a right triangle. So to find this side of a right triangle, when you know the adjacent side, you say tan 62 times 6.8 equals Vy. Which is opposite over adjacent. What'd you get, Keely?
12.8.
All right, 12.8, which we'll call 13. Now, if I drew this to scale, that's a very reasonable answer, because 62 is up here, so you would expect Vy to be much bigger than Vx, because it's a 62-degree angle, so you can evaluate your answer that way. You'd expect it to be more than 6.8, significantly more, because it's a 62-degree angle. Got it? So here we go. Now we want to find
dy.
apogee.
So you do 1/2 GT.
Yes. You use the formula dy equals 1/2 GT squared. Make sure you get that on your card. And you cut time in half because it takes half the time to go up and half the time to go down. You cut the total time, this is total time, in half. You've got to, because going up takes half the time and coming back down takes half the time. All our problems in here are simple, they're symmetrical. We're not worried about air resistance or anything else, or him tripping along the way and getting up and starting it. We're not worried about any of that. Everything is simple, symmetrical. Whatever happens on the one side, happens on the other side. So, what did we get?
20.
How much?
20.
I rest my case. Good luck. Thank you.
So is that pretty much?
That's it.